So yeah, I'm Craig Freeman. I work for Kenzon. I'm a front-end developer.
I'm Kelly. I am a fireman. Didn't do a lot. But technically front-end developer, I guess. So, yeah.
So yeah, we're going to talk to you about progressive web apps today. Really just a fancy term for reliable, fast, engaging, and integrated websites. So throughout the course of this meetup, we'll get into the collection of the existing and emerging technologies that are out there that, when paired together, can bring the best attributes of mobile sites and native apps to your users. Everybody here okay? Okay. No.
No? Feels weird sitting.
Okay, so before we get into that, a little history. Some of you, I heard, were in some of the, what is it called? The boot camps. There we go. So, a little background for you. All right. Well, actually, anybody remember 2005 era, that whole Ajax thing that came around? Yeah, that was a big deal, right?
Me neither.
I mean, it changed the web. It went from primarily static sites with some JavaScript sprinkled in here and there to fully dynamic, interactive experiences. And the best example we have of this from that era that's still around is Google Maps. They changed the game with their use of Ajax, and the Ajax techniques have changed a little bit since then. But basically, they breathed new life into the web. Other libraries like jQuery and other DOM manipulation frameworks came popular around that time, and people started taking the web a little bit more seriously. So around 2009 or so, the iPhone had already begun to change the industry, and many websites had both a mobile version and a desktop version, sometimes separate themes or their own separate native app. And the problem was more and more phones were coming out, and it became cumbersome to tailor a website to handle every permutation of screen size. So in 2010, we started seeing responsive web design techniques, which again just changed the game. So now we could build one site, but adapt it to different screen sizes. So our sites were both easier to develop on or for, and we didn't have to worry about who wouldn't view the site as intended. We were designing for mobile first and progressively scaling up from there. But circling back to Google Maps, just show of hands, how many people use their web application on their computer for Google Maps? Right. What about on your phone? Do you use the web app or do you use the app, the native app? Yeah. Most people use the native app just because it's faster. So I'm going to throw a couple stats at you here, so just bear with me. Google accumulated all these stats recently, and it's interesting because you see that mobile computing use overtook desktop use recently. So while mobile users spend most of their time in native apps, the average person spends about 80% of their time using just 3 apps. And I think the average for installing an app per month was 0. 0 new apps. So users see native apps as a big commitment in space and time and cost. However, they'll visit over 100 mobile websites in a month. The problem with websites is that 60% of global mobile users are on 2G, and 40% of users will abandon sites that take longer than 3 seconds to load. So you can understand how this places a lot of importance on websites being able to be really performant on phones. So what Google is proposing is that we apply the same concepts that we applied to sites to accommodate screen size, the responsive web design. They're saying we should do that to accommodate mobile connectivity speeds. So optimize for the least and progressively enhance the experience as those limitations are removed.
Enter progressive web apps. Okay, so I recently was in San Francisco at Google and did like a whole roadshow on these progressive web apps, and they kept saying this over and over, and I thought it was cute. Progressive web apps are a radically improved user experience, and they define it by using 4 terms. The first one was fast, meaning that it's like quick to load and it's responsive, and the second one was integrated. So it's leveraging like capabilities that are usually native with web APIs, and reliable, needs to work irregardless of your connectivity speed. You say that weird. Connectivity? Okay. Connectivity, speed, and then engaging. Free of distraction, easy to access, re-engages users using things like push notifications when they're relevant, and only when they're relevant. Sounds great, but how? I think that these are all kind of things that we want to accomplish in our apps, but, Google kind of has like a list of things that they're like, this is what needs to happen, this is the gold standard that we're setting. And the first one, which is huge, HTTPS. Secure serving of your site is a necessity for progressive web apps. In fact, for many of the web APIs, like geolocation, a secure origin is required. So you can't even run that unless you're on HTTPS. Having a secure connection, or HTTPS, really means 3 things. Identity, confidentiality, and integrity. The user needs to be able to trust that the site is actually you, not a scammer or a phisher. They can be assured that no one has tampered with the page and that no one's listening in on the interactions between the user and your site. The web has tremendous reach and is frictionless, so keeping the user safe is really important. The next great way that we do this is service workers.
Thank you. This is a smooth transition.
Ooh, I know, I'm trying.
So, more or less, this is a JavaScript file that runs separately from the main browser thread. And it can do a number of things. The things we're going to be using this for, namely, is intercepting network requests, caching, and retrieving resources from the cache. But you can do other things like listen for push notifications, stuff like that. So kind of dive into a little bit of code. This is kind of hard to see. I apologize. We're going to post the slides, so bear with me here. So there's a couple of steps we have to take for service workers to work in our app. First thing we have to do is register the service worker. So we always begin by checking whether the browser supports this, and that's kind of in line with the progressive enhancement of the app. So the service worker is exposed on the window navigator object and can be accessed with window.navigator.serviceworker. So after registering, we have to, the service worker will emit an install event, and in this case, we're just logging a message, but it's a good place for caching static assets that your app might require later. When a service worker is registered, the browser detects if it's new, either because it's different from the one that was already installed, or it just hasn't been installed yet. If it's new, then the browser will go ahead and install that. Next step after installation is activation. The service worker will then emit an activate event when it takes control of the page. And again, we're just logging a message here. But often this is used to update caches. And lastly, and this is just an example, we're listening for a fetch event. This is using the fetch library, or fetch API. So in this case, it's receiving a fetch event for every HTTP request made by the browser, and it's intercepting that. So the fetch event object contains the request, and listening for the fetch events in the service worker is similar to listening to click events in the DOM. In this code, when a fetch event occurs, we log the requested URL, same as before. And we'll get into a little bit more in a minute, but question, go for it. Right. Webpack's got some great plugins that we can use to kind of skip over a lot of this stuff. We're not going to cover those in this talk, but afterwards, I mean, I'm happy to talk about all the different options we have there, just to cut some corners. Because this can be, you'll see in a minute, but it can be a little overwhelming at first. So why don't you talk about some of the caveats?
Yeah. I was supposed to do with like the scrolling text.
Sorry, we'll go back.
Service workers may cause death and get in contact with the service worker. So there's definitely some caveats, right? We all know this. Well, maybe not we all. Sorry, that was a dumb thing to say. But the huge thing is iOS, right? Safari does not currently support this, but it is in production. So it's coming.
Development.
It's in what?
Development.
Is it? Oh. Okay. The webkit just said in development. I didn't read more into that, but there you go. This is happening, people.
Edge is also in development, which I don't think has a preview yet. We'll have some resources later where you can see all the different browser status pages, and it gives you a great overview of what's either being developed or considered or is in progress. Same thing. So, sorry.
Yeah, no. So that's one thing. Another thing is things like push notifications. Like on Android can happen if your browser's closed, but on like iOS or in like Chrome and Firefox, like that can change, right? So iOS handles that a little bit differently across platforms. So that's just something to know. You really kind of...
So whether or not the service worker will wake up from the OS is OS dependent.
Yeah. Okay, yeah, that was it. Caching strategies. So service workers give us complete control of our caching strategy. And that's going to change. It's not going to be one case for all, but these are some of the common ones we see. Cache and falling back to network. Network and then falling back to cache. And cache then network. Okay, so cache falling back to network. If you're building offline first, this is how you handle the majority of requests. So in step 1, you're going to go to your service worker. Then step 2, you're going to check cache. If that's not available, you can go to network and then back to page. Here's an example of what that would look like using the Fetch API. This kind of gives you the cache-only behavior for the things in the cache and the network-only behavior for anything not cached. So that includes non-GET requests, because they can't be cached.
Next one is network, then falling back to cache. So this is a quick fix for resources that update frequently outside of the version of the site. These would be like articles or social media timelines or game leaderboards. So here's an example. This basically gives online users the most up-to-date content, but offline users get the older cached version. If the network request succeeds, then you'll most likely want to update the cache entry so that it'll just be ready to go for next time. This method has a couple flaws. If the user has an intermittent or slow connection, they'll have to wait for that network request to fail before they get perfectly acceptable content that might already be on their device. That's not the best user experience. Could be frustrating. So a better solution might be this third option, which is cache then network. This is going to be ideal for content that updates frequently, like articles or like social media timelines. Here's another example. Again, hard to read, I apologize. But basically this is 2 network requests, one to the cache and one to the network, and they're asynchronous. And the idea is to show the cache data first, but when the network data arrives, that's going to take priority. Sometimes you can just replace the current data when new data arrives, but that can be disruptive when larger pieces of the content, or with larger pieces. Basically, don't hide something the user may be reading or interacting with. And we're going to have other links. These are the top 3 caching strategies. And there's a link at the end for a really good offline kind of cookbook with a lot of different approaches to it. Any questions with the caching strategies? Is it clear why we're caching? Okay. So kind of going back to how we're... Mm-hmm. Crazy, right? Yeah. And so he's what inspired a lot of what we're talking about. He's got a great series, again, which we link to at the end, that just covers everything you need to know, basically. And he's using React and Webpack and a lot of those great tools you were talking about earlier. What's that? He's like a Google PWA evangelist, basically. Cool. So back to implementation. There's other things we can do to make these better experiences for our users. The next thing is the web app manifest. Why don't you take this one?
Yeah. This is like a huge piece of the PWA. It's just a simple JSON file, really easy to read. Love this. It's not complex. This is my favorite part of PWAs. Okay, but it tells the browser about your app. It tells it how to handle your app or how to display your app. So it's great. Let's see. Okay, so this is a web app manifest that I had on one of my sites. Kelly really loves PWAs and can't think of a long name. That's the whole thing. But
fit in the
no, it doesn't fit
desktop.
Well, and it definitely wouldn't fit as like a app. So you have the option to give a short name, which in this case would just be Kelly. And then you have a list of icons and different sizes. So it will pick the appropriate one. And yeah, so that pretty much just defines how it's going to look on your home screen, which is great that you can control that.
So you can do, you can control orientation, you can control whether it's full screen or not.
I'm getting to
Oh,
that.
excuse me, I'm
God.
sorry. Jumping the gun.
Yeah, it's coming,
I'll
Craig.
just go over here.
Okay, we can also define a splash screen. So this is when when your app is spinning up before the first paint. This is what's going to be displayed, and it actually automatically creates this just using the name, your background color, and your icons. You don't even have to make this. It's just boop. Just add those, couple lines of code. It's great.
But you can also define your own, right? Yeah, pretty simple. You should pay attention more.
Yes.
Sorry about that.
A couple other options that we can find in the manifest is the start URL. So that's like your core URL from the app, the starting point for any app launch. You can also control whether you show the URL bar when you open up that PWA, which is kind of cool that it's not. Then that really feels like this native experience when that URL bar is not sitting up at the top. And then you can control orientation. Most things are going to be portrait, but I mean, if you're playing a piano on your phone, then maybe you want landscape. So that's great too. Okay. So on Android, progressive web apps have like this first-class support, and they behave like native apps. And then it supports like this theme color. So when you're switching in between tasks, the app bar color changes. Let's see. Okay. But yeah, that's just Android. The manifest, though, is supported by Chrome on Android, Firefox, and Opera. Plus, Microsoft has indicated support for the Edge. It's in development on Safari. So until that's released, you can still use the Safari traditional like meta tags for the colors. Yeah.
So continuing on with what we can do to implement this, there's a couple optimizations that we can do, techniques that basically demonstrate how progressive web apps stand apart from a traditional website. First thing is including an app shell. And this is just an architecture for the bare minimum styles and scripts that you need for when your app first loads. It should be quick to load. It's going to be immediately cached using our caching strategy. And that way, on the second load, we're able to just quickly spin up a UI. So here are some of the benefits. Like we mentioned, just it's reliable, it's performant, and you're going to get those native-like speed.
Oh, something I really feel important, and like the reason why I love progressive web apps is, sorry, you went too fast. Okay, is the, so in app shells, you have like this economical use of data. You're only loading what you need just right then. And that's so important. And the reason why progressive web apps are, I like just so love them is that like across the world, the, like the ability to have, or like data, having data is hard and it's expensive. And so these apps like that load maybe instantly for us on our phones, like, in another country, take time. And, if users are leaving these sites, if your, page isn't loaded under 3 seconds, then there's so much content that other people aren't seeing, right? And it's so important to, like, I don't know, I feel like this is, like, my calling in life is to, like, reach people around the world, and, like, that's how we make global change. And, the app I'm building at work might not do that, but maybe if I can, like, give everybody in the world access to something neat and that can change their paradigm of things, like, then that's, like, super powerful. And that's why, like, this is all kind of new and all maybe unsupported on, everything, but, like, I think that there's, like, a real thing behind this and a real mission behind this, and I think that that's really important. Sorry, I had to talk about that.
Very important bullet point. Okay, so the next thing we can do is optimize page load. We're going to cover a number of things here. The PRPL purple pattern, we'll touch on that, and code splitting, route-based chunking, universal rendering as well. We'll talk about offline accommodation and some of the tools that we can use to develop with. So I'm not going to cover this too much. This is more just a pattern to keep in mind, but basically this is a pattern for structuring and serving PWAs with an emphasis on performance of app delivery and launch. So it's something that Google is still kind of working out. This comes from what's the web components library they have? Polymer. This comes from Polymers, which is just always iterating. So it's still in progress, but this gives us a lot of focal points that we can borrow from. So Kelly came up with what you need is what you get. This is basically what this pattern is.
They had a great opportunity that they just totally missed. But I guess purple's fine.
Purple works, yeah.
They certainly didn't ask me.
Effectively, the server and the service worker work together to pre-cache the resources for the inactive routes. When the user switches routes, the app will lazy load any required resources that haven't been cached yet, and this creates the required views. Repeat visits to routes should be immediately interactive, and that's where the service worker helps a lot here. So just to kind of dive a little bit deeper in there, we're not going to cover this in the workshop, but it's kind of good to know just to go off and read at your own convenience. But code splitting is one answer to the problem of monolithic bundles. It's the idea that defining split points in your code, and it can be separated into different files that are lazy loaded on demand. This improves the startup time, like I said, and minimizes our time to interactive, which is the metric we're aiming for to decrease the most. The second thing here is route-based chunking, which is more or less code splitting by route. So I have, again, resources that explain this in more detail, but basically we're defining what resources we want to deliver at specific routes. Continuing on, we have universal rendering, also known as server-side rendering, or not just server-side, isomorphic JavaScript. Using JavaScript, or more specifically, making resources available for both the server and the client side. So by doing that, the server can deliver the markup quickly on the initial page load, and then the client can recognize that markup and see where it needs to tie back in, and then the code rehydrates the view, and then the app proceeds as normal. We also get the benefit of sharing code using some different tools that are out there. And an added benefit is we eliminate the flash of unstyled content. Next thing is the offline accommodation. Not going to go into too much detail here, but from Google's recommendations, this is for the network resources necessary to load the app while offline. We're going to use the cache API, which is just part of service workers. For all of their data that we need to deal with, we should stick to IndexedDB or like the built-in SQLite databases. And they recommend using a promise wrapper library. You want to talk about it?
Oh, yeah. Lighthouse is super cool. Who's used Lighthouse? Yeah, okay. It's really neat. So Lighthouse is kind of like built into the Chrome DevTools now. It's just like there's like a little audit tab, and you can click it and run an audit. And it's will actually like take your website and like do all these metrics against it and show you where you can get better, like what you can do better, give you kind of a score. And of course, that score is all loosely based. 100% is not the goal, blah, 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 you know, but it really shows you what you're missing in your app and what you can add to it. And it actually like gives you step-by-step instructions like, hey, you could do some route-based chunking here, or you could add a manifest.js, .json. Let's talk. JS? JSON, yeah, it's a JSON file. So it's super helpful for kind of like measuring your app. And you can also, not in Lighthouse, but in your Chrome DevTools, like look at your service workers anytime you have a service worker running. If you guys are doing this, something super important is like, if like that service worker, like it is hanging around, you can like clear it, because sometimes that it just like causes problems all the time. So that's super, super helpful to see. You guys will see that in the workshop, like, and actually use those tools. So, yeah, Lighthouse is super cool. Time to beat is 5 seconds for the first visit, and this is time to interaction, not perceived time, not like app shell time, but time to like being able to interact and click on stuff on your page is less than 5 seconds for the first visit, and 2 seconds for the repeat visit once that service worker is installed, which, something to mention, service workers do not run on your first render because they haven't been installed yet because they come from the server. So it's for the repeat visits. This is something that kind of tied into like app shell and optimized page load is like to have the skeleton screens. If you guys have seen this, this is like perceived perceived performance, and this kind of just lets your user know what to expect. So it's going to be the structure of your app, but without any of the data, and it shouldn't change. Like this should be like it shouldn't grow all of a sudden when the page loads. This should be exactly kind of where the data gets plotted, right? So it just gives your user something to expect, lets them know that something's happening, perceived performance.
It's like the new age spinner.
Yes. Yes. Yeah. Yeah, how I've done it in the past has been like inline CSS. And I believe there's different ways to go about that, but that's been the best way for me so far. So. I just do it as an inline style. Yeah, yeah. So, yeah.
So the last thing we added here that you can do to add to your, or to create and develop these progressive web apps is just add more progressive enhancements. Progressive enhancement is just the idea that we can incrementally add in features and functionality as they're supported by whatever device you're using. So the more the browser supports, the better the user experience should be. And I feel like this is really the core of progressive web apps, and service workers are the biggest example, the biggest and most useful example of progressive enhancements. So I mean, we don't need them technically, and our app will function fine without them, but they do add a huge value to the user experience. A couple other examples might be like the web push notifications that you mentioned earlier, maybe like background sync API, and I mean, there's the list is endless. So yeah, workshop time. Before we do that, any questions? We covered a lot in a short amount of time. Service workers, I feel like they're the most complicated, but once you get into them, it's fairly straightforward. The caching strategies can get messy, but we have those resources that you can use to follow along and try them out and see which one works best for your application. We had this really cool idea of an app to make, and about 4 days ago, we're like, you know what, this is awesome, but it's not really a good example of progressive web apps. It's just like a native app, or what should be. So we scrapped that, and we're just going to run through the Google Code Lab progressive web app, which I do have an example of. Here. Yeah, of course.
Kind of curious.
That's definitely like a struggle, right? And making value behind this. And it's something that I've just been kind of trying to like fit in when I have extra time. Okay, let's get this performance better when I have extra time. Trying to be super thorough. Like, hey, here's a detailed report of what I've done and how this has enhanced the site, how we're faster to, page load, how we're faster to interactive or even a perceived page load. But that's super difficult. I feel like that's a huge struggle within just the industry in general, is making people understand why it's so important to put in the extra time for this. I feel like there's some simple things we can do, though, like the manifest.json. That's just a JSON file that we throw in. So, like, we can make these little enhancements just really, quickly. So, yeah, that's definitely a struggle, and I've definitely run into that. I personally just try and fit in where I can.
It's hard to find clients that are on the cutting edge of technology, right? The problem with selling this is that it doesn't work across the board yet. It's on its way, but it's not quite there. We're trying to get everyone thinking about this stuff, so when it is available, we're ready to go. I think that the Lighthouse API, it gives you a report at the end. And I feel like that tangible thing is something that you can bring to a business person and say, here's value. You're able to see those metrics and see how you've improved them. And I feel like that's the way that you're going to be able to sell this to an employer or a client.
That answers your question.
Yeah, of course. Actually, that example you gave of being offline, either on a plane or just in a remote area, another progressive enhancement we talked about was that background sync API. So you could do all of the things you need to do on your app while offline, and then once you get connectivity, some reliable connection, it would just sync up with whatever server and get you fresh data. Yeah.
Another company actually doing the Chrome Dev tool, file it to your and then show them what the site looks like. People always take it. Ask it, would you wait for this? And
yeah.
Usually I think Google actually said it seconds. Bounce rate of 3%.
Yeah.
Yeah.
Pretty high.
Yeah.
So that's another great way to actually.
That's actually another great progressive enhancement is offline Google Analytics. You know? Yes. What? Just to apply it?
Yeah.
I mean, it really depends what you want to do. It depends on your app as well, I guess. I mean, it's obviously going to be easier from a greenfield app, but I don't think retrofitting an existing app would be terribly difficult. Can't give you like a number, but
depends on what caching strategy you go with. Yeah, it changes. But there's when I was there in San Francisco, different approaches to this, and it's just either you take an app from brand new and implement it that way, or you do it by feature, or you do part of your app. So yeah, it ranges so much. But
yeah,
I mean, if it could save you a couple seconds on load, that's potentially millions of dollars for a lot of sites.
I mean, it also depends on how much you choose to implement. Like, there's a lot of pieces at play here, and you can potentially add a number more. So I don't have like a solid number because I don't have like a specific app for you. But what this workshop will show you is basically an app that doesn't have any service workers, and then we'll go ahead and add that in hopefully less than an hour. So we'll at least get that piece, and I feel like that's one of the most critical pieces. So existing app, hopefully less than an hour for a very basic caching strategy. That helps it all. That's the end goal. So currently it is dependent on certain things, for certain things, namely the service workers and the manifest.json don't work in iOS. It's in development. We're trying to downplay that because eventually it'll be there, but we wanted to get people excited about all these extra features. So one of the takeaways I want everyone to have from today is just be on the lookout for these new features coming to those browsers. So right now it's restricted to basically Android, and there's degradations you can do for iOS and Windows browsers, but they won't be quite the same experience. They'll eventually get those features, and since you've already written it as an enhancement, it'll just be ready to go. That's a good point.
A lot of the case studies I've seen, just by following kind of like the purple principle, and thinking about these things like time to initial render and all this stuff, actually like decreased time on the iOS apps even, or on the iOS. Yeah. So there's like these principles like are super solid and platform agnostic.
Cool. So this is the workshop app we're going to be working with. It's pretty basic weather application. I'm going to have difficulty seeing where the cursor is, so bear with me. But basically we have the refresh option here. Take care. And we can add new cities to track. And again, I can't see my cursor, so we'll add Seattle. I wonder what it's like there. Cool. So this is the app, and basically we're going to add service workers. We're going to add a couple other extra features. I'm going to run Lighthouse on this real quick just to see what we're starting with, and then once we're done, we can compare afterwards. So I'll go to the Audit tab, and we'll just let this do its thing. And see what reports you want it to give you. So I'm not doing anything right now. It's just kind of doing its thing. Cool. So this just reset the app. So this is probably in my cache already, which means now that I add anything, or if I refresh, it'll update this data. You can't really see it, but we have a progressive web app score of 45, and there's 6 failed audits. Performance score of 0. Good. The opportunities there. Accessibility is 91%, and then best practices are 92. And these are based off of Google's web development standards, and I'm pretty sure those are open source. That they kind of help steer, but they're just general best practices to follow. Cool. So any questions with what we'll be working with? All right. I guess we'll take a little break. If you guys need to get on Wi-Fi, let me know. I'm happy to walk around, and if you have any questions, we're happy to answer any.